Newton, Galileo, and Einstein transformed our world. And now their successors are doing it again, with groundbreaking discoveries that are making us rethink everything.
Everybody told me I was nuts.
And the revelations could save lives and power the world with clean energy.
This will be the biggest thing that happens in any of our lives.
But we'll start with the telescopes launched from Florida's Space Coast that are delivering some big surprises. All in this edition of Breakthroughs in Science. The James Webb Space Telescope, or JWST, continues to amaze us. Look at this. It showed us the pillars of creation, or star nurseries, 6,500 light years away. Here's a picture of an infant star. And here's the Crab Nebula, formed by the gas and dust of a dying star. The Orion Nebula used to look like this to us, and now it looks like this. This is 1,300 light years away, and the telescope found 40 new pairs of planet-like objects within it. And JWST found a lot of exoplanets across the galaxy. Here's a rendering of one with sand clouds, 200 light years away. And it's found some within what we call the habitable zone, or just the right distance from their heat sources to potentially support life if other factors line up. And some of them with the possible presence of water. And we know the future implications of that.
NASA has been searching for extraterrestrial life. Okay, there's an entire branch that's in searching for the water on the planets, on other planets, and water on Earth. Wherever we have liquid water, we have life. So one of the mantras of NASA is follow the water.
But the JWST is also revealing some things that are making scientists question our basic understanding of how or when the universe came to be. And to see why, let's start with our understanding of light. If you hang a crystal ball or a sun catcher on your window, it'll disperse the light and project an evenly colored light spectrum on your wall, from the elongated waves of red to the more squished waves of blue. But if we're observing a light spectrum from a source moving toward us, it would squish the incoming waves and make the spectrum more bluish. And likewise, if it was moving away from us, it would flatten and stretch the incoming light waves and make that light spectrum look more reddish. And this is how we measure whether things are moving toward us and at what speed, or away from us and at what speed. And it's how we know how so many stars and galaxies are redshifted and moving away from us, and why we say the universe is expanding, and why we can then reverse engineer and say, well, everything used to be closer and closer and closer together to a point in which everything exploded from a big bang around 13.8 billion years ago. But that's where the James Webb Space Telescope is now throwing scientists for a loop. See, the James Webb Space Telescope can see much farther out than Hubble ever could, and that means we can now see how things looked much further back in time, near what we think is the beginning of time itself.
We are looking at the universe as it was in the far past. So when we look at some of the most distant galaxies, the light has been traveling to us for over 13 billion years. And so we're literally looking at those galaxies out as they were back in time, very soon after the Big Bang at the beginning of the universe.
And we're seeing things that known laws of physics say should not be there, like mature, intricate galaxies some 200 to 300 million years within the Big Bang that we think should have taken much longer than 300 million years to form. Apparently, either galaxies form much faster and differently than we thought, or maybe dark matter and dark energy played a role in making them, or maybe we miscalculated the date of the Big Bang, or was there a Big Bang? This telescope, launched from Central Florida, is now challenging our understanding of the universe, and it's raising a lot of new questions. Which brings us to this image it captured near the frontier of time and space, which fittingly reveals something that looks a lot like a red-shifted question mark. A perfect illustration for where we are and where we're heading.
The frontier between what you know and you don't know should excite you. It should call to you. It should say, I'm here, come get me. Come find out what you don't know today.
And there is something more, something incredible calling to us that scientists also did not expect to find that far and that close to the beginning of time. A supermassive black hole in a galaxy more than 13.2 billion years old. And scientists who interpreted the data and images say this super black hole did not form from a collapsed star as we commonly think, but rather a massive gas cloud. Now, before we spell out what that could mean, let's back up a bit, because black holes, of course, suck in everything in their paths, including light, and everything pulled in would be surrounded by darkness. And as per Stephen Hawking, they also emit radiation until they eventually dissipate. And what happens to all that information inside, well, that remains a mystery. But these new discoveries may be helping us to solve that mystery. That can help us figure out the origins of existence, or at least making us seriously question what we think we know today. So again, going back to what this all could mean, it provides more evidence the Big Bang may either have occurred earlier than we thought or not as we've envisioned. And it helps drive theories that massive black holes may vacuum in all that they can and eject their contents into alternate dimensions as they slowly dissipate. And in doing this, black holes may be like cosmic seeds or cosmic pregnancies in which material is sucked in, fused together, and then reformed to grow something new in other dimensions we cannot perceive. In other words, black holes could be Big Bangs in reverse that could give birth to baby universes, which then expand and grow. And as such, our universe could have been born from a black hole from a mother universe. This and other theories are certainly fascinating, and they're gaining interest based on what scientists are finding. And as for that mysterious presence of dark matter and dark energy, well, all of this is also driving theories that our universe itself may be stuck within a much larger black hole, and that all of that dark energy and dark matter that the laws of physics say surrounds us, well, that could be the black hole that we are in. Of course, that would still leave the mystery of ancient galaxies that may appear to be older than the Big Bang and time itself. But in yet another mind bender, these new discoveries are also feeding theories that time itself is merely an illusion, and that the events of the past and what we perceive to be happening in what we call the present and in the future are simultaneous, and that we only comprehend them in sequence due to the limits of our minds. Something we writers should be able to remind our producers when our scripts run longer than what they had in mind. Coming up, Nobel Prize winning discoveries take us inside the weird world of atoms.
Anything that can happen, happens.
See how it's leading to breakthroughs in medicine and radically faster computers. In 2022, John Clauser won the Nobel Prize for proving what Einstein thought was impossible and what can sound too weird to believe, but it's true.
Everybody told me I was nuts, that I would ruin my career. Everybody knew what the result would be, wasting time and money, wasting my career.
His work confirmed that tiny particles or photons behave differently based on whether or not we're observing them, and that they lock into a specific place and time because somebody observes them. Otherwise, they exist in multiple places at once and move in all directions at once, or exist in a range of all possibilities under the laws of quantum mechanics.
And in quantum mechanics, essentially anything that can happen, happens. So anything that isn't forbidden is mandatory.
And since that's how it works in the world of very small things, physicists say, well, maybe that's how it also works in our larger world. And that drives the theory that anything we can do also does really happen. And while our consciousness may follow a specific track, all of the scenarios play out in alternate timelines or parallel universes, or what physicists call many worlds. And that's driving these growing number of movies and shows that take this concept of a multiverse and run with it.
There was a vast multiversal war. Countless unique timelines battled each other for supremacy.
There may be these different timelines. There may be these timelines existing simultaneously, but there's no communication between them. The only communication between them happens for very, very small particles.
But getting back to Clauser's Nobel Prize winning experiments, he confirmed something else that may be the weirdest part of all, because he verified that particles or photons have partner particles and that they're somehow entangled, so that the act of observing one of them doesn't just change the state of that one particle, it also instantly alters its partner particle, even if its partner particle is on the other side of the universe. Now, believe it or not, scientists are already using this discovery to teleport stuff.
Ready to beam up, Jim?
Well, it's not like Star Trek. They are not beaming people from planets to spaceships, but they are able to get a photon to interact with a second photon, and in doing that, bounce it or beam it or teleport it to that second photon's entangled partner far away. And if we can keep advancing that technology, those Star Trek transporters may not be that far-fetched at some point in the future.
This is just the beginning. There are so many things to come, and this is what makes it so exciting.
In the meantime, engineers are using the laws and discoveries of quantum mechanics in our computers and to improve encryption to make it harder for hackers to snoop on us.
Many things are going to be more secure, and that, of course, can impact everybody, right? From the banks to the governments, from even your transactions that you do with your credit card.
For example, they're developing ways to transmit two streams of entangled photons so that if a hacker disturbs one of them, the other will instantly alter and sound alarms.
If you lose your photon, you will realize it, which then makes very easy to check if somebody is eavesdropping on the information you're transmitting.
And that's just the start. Engineers are also developing quantum computers that can be millions of times faster and more powerful than the computers we have today.
Honestly, they're not 100% sure what exactly they're going to be able to use it for yet, except that it's very powerful and can generate very complex numbers.
Well, to understand what a quantum computer is and how it works, let's start with traditional computers. Computers we use today work by transmitting and receiving rapid pulses of electricity, and those electrical pulses carry intricate codes, always in a string of zeros and ones that flow in and out of the chips, or the brains of our computers. And the chips coordinate and interpret and transmit the codes to our monitors to form images, to our apps to perform calculations, and so forth. It's basically just a running flood of zeros and ones on bits, and each bit can either be a 0 or a 1 depending on how you code it, and that string of bits then tell the computer what you want it to do.
When you have a traditional computer, it's on or off. It uses these things called bits, 1, 0, on, off, yes, no.
Well, a quantum computer does not do that. Instead, it uses subatomic particles within tiny circuits called qubits, and those particles or qubits are entangled or linked together so that they connect and function in tandem, sort of like the neurons in our brains. And as strange as it sounds, as we learn from the laws of quantum mechanics, those subatomic particles are also in different positions at the same time.
Quantum computing is both on and off at the same time. It's this weird headspace.
In other words, while a bit can only be a 0 or a 1, a qubit can be both at the same time, or part 1 or part 0. In other words, a qubit can run in different directions at the same time, or to put it another way, can multitask in ways that traditional computers cannot. Now, for an analogy, think of being stuck in a maze. Well, we'd find our way out much faster if we could run in all different directions at the same time. And again, as odd as it sounds, that's what qubits can do.
We'll stack these things called qubits together, and in really cold rooms, they can use them to measure multiple values at once using quantum mechanics.
And in early tests, we found tasks that have bogged down our most powerful traditional computers that quantum computers have been able to solve within a couple of minutes.
What would take the world's fastest supercomputer years, thousands of years, to do that same calculation. And in the field, this is known as quantum supremacy, and it's a really important milestone.
Well, they're still a long way from going commercial, but when they do, they'll likely make all of the computers and smartphones we currently use obsolete, not just because the devices we have now would be so much slower, but also because anyone with a quantum computer would be able to hack them, and likewise, a quantum computer would be near impossible to hack. And scientists hope these exponentially faster and more powerful qubits could give us precise times and locations of natural disasters, and develop far more advanced medicine and solve our traffic woes and help us take the next giant leaps in space and help us rein in the effects of climate change.
Well, I think the good news is that we're going to be able to find the secret of life itself. The aging process, cancer, Alzheimer's. We're going to be able to cure diseases that are unimaginably difficult today. So that's the positive aspects. We're going to be able to change the world around us. But look, let's face it, there are also some dangers involved. In fact, the CIA is very much interested in quantum computers because they could break any code of any nation.
Tech analysts project the first generation of quantum computers will go on sale by the end of this decade and will take off in the 2030s. Coming up, capturing the movements of electrons could detect and snuff out cancer before it grows beyond the size of an atom. Well, 3 physics professors are now giants in the world of science. Ferenc Krauss in Germany, Anne Lallier in Sweden, and Pierre Agostini, professor emeritus at Ohio State University, won the Nobel Prize in Physics in 2023. Now, they may not be household names, but their work could transform households all around the world because they won the Nobel Prize for capturing and tracking the movements of electrons in ways that you may not believe. Because up to this point, the micro-universe, the world of electrons flying through clouds within atoms, have been a blur to us. And that's limited our understanding of how and why they behave as they do. But thanks to these physicists, that has changed.
If I take an image, we use our pulses like a very short camera flash, and we try to follow the motion of the electrons.
And here's an analogy to help explain what they did. Think of a hummingbird. Its wings flap so quickly it just looks like a blur to the naked eye, and most cameras as well. See, it takes a very high shutter speed to be able to see what its wings are actually doing, what it looks like when they're in motion. Well, the same concept applies to electrons, which of course we cannot see spinning around with the naked eye, but we know what they do and what they produce. For example, when charged electrons from the sun are caught in our atmosphere, they produce the northern lights. But electrons do a whole lot more than that. They're the workhorses of everything, of chemical reactions, of how stuff holds together or falls apart, and of how our bodies function or fail. But they're so small and move so quickly, scientists have not been able to focus in and lock into them until now, because we're talking about something extraordinarily small within an atom that travels at speeds of 43 miles per second. But the Nobel Prize winners figured out how to capture their movements by using short pulses of light, sort of like putting a strobe light to a moving fan, but on a ridiculously faster scale of attoseconds. An attosecond, that's 1 quintillionth of a second. And this can help us drive new breakthroughs in a couple of ways. First, the ability to measure electrons in this way can help us detect minute changes in people's blood samples, which could detect some serious diseases long before any symptoms appear.
That's a big advantage, because this means that you have a sensitive method that can detect the disease at a very early stage, for example, lung cancer.
Detect cancer before it otherwise becomes detectable. Some doctors and scientists have already been working with devices commonly known as cancer pins. They extract molecules from our bodies to detect very small amounts of cancerous tissue. Imagine detecting increasingly smaller specks of cancer to the point a doctor could say that molecular fingerprinting, which is what they call it, molecular fingerprinting indicates previously undetectable cancer that we can now nip in the bud before it spreads beyond the confines of the atom. That's just one example.
We can study electron dynamics in atoms, molecules, and in condensed matter, and understand in a totally different way how things work.
This could also help drive huge leaps in digital encryption and quantum computing, and it can also improve, if not revolutionize, how we transmit electricity to make it far more efficient, and design smartphones that are far more powerful and efficient and far more effective. Batteries for gadgets, electric cars, and homes.
Coming up, the nuclear fusion revolution is taking off. We'll show you how and when it could power our homes with safe, clean, and much cheaper energy.
Of all the scientific leaps we've made recently, none may affect our lives as much as developing nuclear fusion. In short, it could save our planet by ending our reliance on fossil fuel and produce safe, clean energy that could eventually power the world at a fraction of what it costs today.
When we make this real, build the plants, this will be the biggest thing that happens in any of our lives.
Now we're talking about fusion as opposed to fission. Fission means breaking atoms apart to get huge bursts of energy like this. That's a nuclear blast caused by fission. America figured out nuclear fission back in 1945 and first used it to drop the atomic bombs on Japan that ended World War II, and then figured out how to create a sustained fission reaction to power nuclear power plants. But of course, nuclear fission power stations do generate radioactive waste in the process, and also potential accidents can cause a radiological disaster like we saw with Chernobyl. So for decades, the holy grail of atomic physics has been to figure out how to get a safe, clean, and even stronger burst of energy by fusing atoms together instead of splitting them apart. That's fusion, which can produce 4 times the energy as fission does and with no radioactive waste. That's what the sun does to produce energy, fusing hydrogen into helium. And after decades of experiments, scientists finally figured out how to do it successfully in a controlled setting here on Earth.
Fusion is pretty much literally the power of the sun brought to Earth in a controlled manner.
Now, prior efforts failed because it took far more energy to cause a fusion reaction than the energy released from it. But the experiments at the Lawrence Livermore Federal Lab in California finally paid off by producing more energy from a fusion reaction than the energy used to cause it. And the scientists did it with high-powered lasers. Basically, they put a very tiny pellet of hydrogen in a small canister and then fired 192 lasers into it. The lasers sear it from all sides, burning or fusing it into itself until the canister heats up to 5.4 million degrees Fahrenheit. And that's how they fuse hydrogen isotopes into helium in a way that releases more energy than the energy we spend firing those lasers. And the nuclear physicists say advancements in artificial intelligence and quantum computing in the next decade could also help speed things along as we improve and build out a network of fusion plants. Well, thank you for watching this edition of Breakthroughs in Science as we live through this new renaissance and more discoveries yet to come.